Question 1 tells you the speed the car is travelling at, 50 metres per second, and then because it's hit from behind, its speed increases to 90 metres per second, and it says it takes 0.2 seconds for the speed to increase. And the first thing it asks for is the acceleration of the car. It says in terms of g, but first of all, let's just find the acceleration of the car. We know the final speed, we know the initial speed, we know how long it took, so it should be really easy to find the acceleration, change in speed divided by time. Once we've got the acceleration of the car, notice what the question asks for. It says in terms of g. This is quite a common thing when talking about accelerations. It's not particularly scientific, but it does help people to sort of get a feel for how big an acceleration is to compare it with the acceleration that gravity causes. So it's quite common to quote accelerations as being so many g. So for instance, if my answer that I'd worked out, if I'd worked the acceleration out to be 30 metres per second squared, and I wanted to express that in terms of g, then I would take 30 and I would divide by 9.8. That would give me an answer of 3.06 g or 3.1 g. Now, I've just made up the number 30, that isn't the answer to the question, but whatever answer you get for acceleration for the car, if you divide it by 9.8, then you can say the acceleration is so many g. For part B, to find the impact force on the car, well, you've worked out what the acceleration of the car is, and you know the mass of the car, so it should be quite easy to work out how much force is required to give that much mass, that much acceleration. And for this it's important that we are back to thinking about acceleration in its proper units of metres per second squared. Okay, question 2. The front end of a certain type of car of mass 1500 kilograms travelling at a speed of 20 metres per second is designed to crumple in a distance of 0.8 metres if the car hits a wall. So calculate the impact time, so how long does it take the car to stop if it hits a wall at 20 metres per second? So it's got to be a SUVAC question, and we know the distance it travels while it's stopping, because that's how much the car is squashing. So 0.8 metres is S. We know the initial speed. We know the final speed must be 0 because the car's coming to rest. And we're trying to find the impact time. So we've got U and V and S. We're trying to find T. Well, there's a SUVAC equation in there somewhere that will do that for you. You've done that often enough now, not to need me to do the example for you. Part B asks you to find the force. Well, we're going to be using force equals mass times acceleration, so I think we're going to need to find the acceleration. And if we've already worked out the time it takes the car to stop, and we know how much its speed changes by, because it starts at 20 and goes down to 0, so we know the change of speed, we've just worked out how long it takes to stop, so that should be easy to find the acceleration. And when we've found the acceleration, we use F equals ma, and we find the force. Right, question 3 is about the bumper of a car. And the first thing we're asked for, the deceleration of the car from 3 metres per second to rest in 0.4 seconds. So I don't think we need any of the data that's in the question there. If something's travelling at 3 metres per second and it comes to rest in 0.4 seconds, find its acceleration. Change in speed divided by time. Part B, to find the impact force on the car. Well, if we know the acceleration of the car, well, the question called it deceleration, but of course it is acceleration, it's just it's slowing down. So we know the acceleration and we know the mass of the car, so it should be easy enough to work out what the force would have to be. Question 4 begins with a lot of data about a vehicle and a passenger in a crash. And the first thing it asks for is the deceleration of the passenger, in other words the acceleration of the passenger. We're expecting a negative answer. So what do we know? We know the initial speed of the vehicle, so that must also be the initial speed of the passenger. And we know that the passenger is coming to rest, so we know the final speed. There's no information about time in here, but there should be some information about distance. The distance travelled by the passenger while the passenger is stopping. And if we have to look at all the data in there, the car travels a distance of 4.5 metres, but the passenger travels 0.5 metres relative to the car. So you should be able to work out from those two numbers just how far the passenger travels while she's being brought to rest. So part B says calculate the deceleration of the passenger in terms of g. Well, you already know what the deceleration is, or what the acceleration is. You know it's 62.5 metres per second squared, and it says what's that in terms of g? So how many 9.8s are there in 62.5? And the last part, the resultant force on the passenger. Well, if you know what the acceleration of the passenger is, it's this figure here. The book calls it deceleration of the passenger because the passenger is slowing down. So if you know the acceleration and you know the mass of the passenger, finding the force on the passenger should be very straightforward.